All right, we are here doing 7.4 rhombus, rectangle, and square. These are specialized parallelograms, and that's what we'll focus on. Of course, you need to write down on page, let's go ahead and get that out. On page 350 through 353, you need to write down all the theorems and all of the corollaries. Okay, I'm not going to spend a bunch of time doing that. I want you to do that on your own. I'm going to go over kind of the differences, just like I did with the parallelograms, of what makes them special. Okay, so we're going to, we start with the rhombus corollary and move on. We also need to know the definitions of them. So make sure you have that down. A rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles, and a square is both a rhombus and a rectangle. I guess your book says it is a parallelogram with 4 congruent sides and 4 right angles. So we're going to kind of go over that, the basic elements of them. And so I'm just going to kind of write down so you can make sure you get the highlights to do the work. A rhombus, okay, has 4 congruent sides. 4 congruent sides. Okay. Also, what's a big deal and difference is a rhombus has 2 kind of things with diagonals. Okay, so the diagonal for a rhombus, the diagonals are perpendicular. Okay, so make sure you know that. That's, of course, theorem 711, rhombus diagonal theorem. And then opposite angles in a rhombus. Diagonals bisect, so the diagonals all right, let me get something under there. The diagonals bisect angles. And I'm going to show you what that means real quick here. So we'll do our best freehand rhombus here. Okay, not sure that those sides are exactly equal. We actually could see if it was, but that's not the point. So I'm going to mark it so that you know it's a rhombus. Bam, 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 bam. All right. So diagonals. What this is going to do, and I'll draw this diagonal here. And then I'm going to label some things. I'm going to call this angle 1, angle 2, angle 3, and angle 4. Okay, angle 1 is going to equal or be congruent to angle 2. Okay, because that diagonal has bisected. Okay. And it's going to end up being where basically all these angles are congruent. But angle 4 is congruent to angle 3. Okay? And the same thing would happen for these angles if I did a bisector here. Those would be equal. Okay, so that's rhombus. Let's move on to the next one, which is rectangle. All right. So rectangles, well, first of all, a rectangle has 4 right angles. And that's what the definition and what the corollary states. And again, these corollaries are sub-rules of the parallelogram theorems. All right. Also, with the rectangle, diagonals are congruent. Okay. So the diagonals are congruent in a rectangle. Okay. Now square. And really, square, there's nothing extra to it. Basically, what a square is both a rhombus. Okay, it's silent H. Don't forget the silent H. I always do. And a rectangle. Okay. Okay, hopefully that guy has not been there the entire time. I didn't realize he was on there. Well, I'll make him go away now. So both a rhombus and a rectangle. And so that means a square, all these things are going to be true. Okay, 4 congruent sides, diagonals are perpendicular, diagonals bisect. 4 right angles, diagonals are equal or congruent. And squares both of those. So that is what that is. Okay, and so you're going to get an assignment. Okay, and so I'm just going to kind of go over how you're going to do it. The first set, we're going to decide if something's true, always or sometimes true. And so here's what's hard about it, is people will try to do that in their head as opposed to just drawing your shape. And so we don't know what it's going to be. So it says draw a rhombus, so I'll draw a rhombus. Or do the best I can. That's probably more of a parallelogram. But let's see here. So number 3, here's my rhombus, and this is J, K, L, M. And so it does have to be in tracing order. So don't put the letters, don't switch K. Well, you can, it's hard to mess this up, but just, I've seen it done. So don't just put it in order. So J, K, L, M. Okay, decide whether the statement is always or sometimes true. Draw a diagram and explain your reasoning. Okay, L is congruent to M. L is congruent to M. Okay, so notice that there's no choice of false. It's either always or sometimes true. Okay, in this example, it would definitely be false. But in this example, L would be congruent to M. Okay, because they'd both be right angles. Because a square is also a rhombus. And so in this case, 3 would be sometimes true. Because the only time it will be true is when the rhombus is also a square. Okay, so all rhombuses are not squares, but all squares are rhombuses. So just remember that's how it works. So I'll let you do the rest of it. Okay, you're going to look at some shapes and determine what they are in 9 through 12. Okay, in 13 through 16, we're going to kind of look at some shapes. And this is where some of you get confused. I would definitely, it doesn't work like that. I would definitely draw out your shape, even though it's going to be on the computer. And get that done. And of course, I need to do it bigger for the camera. Okay. And so, and there it is on the ground. So G, D, E, F. G, D, E, F. Okay, this is 13. And so it won't be on your computer, but you will see it next. So it has a bunch of things. It says 27. Find the measure of the numbered angles in a rhombus. Okay, so remember the rhombus, diagonals bisect angles. So it gives you this, 27. And it wants you to write down answers here. So I'm just going to start here. This is also 27 because it's bisected. Because a rhombus is also a parallelogram, I know that this angle, this whole angle, equals this whole angle. So this whole angle is actually 54. So this whole angle is 54. But with the bisecting, I know this is also going to be 27 and 27. Okay. So how am I going to find these other angles here? And how I'm going to find this angle right here in the middle? Well, I know that diagonals in a rhombus are going to be 90 degrees because diagonals bisect each other in a rhombus. Okay, so I got that one. So, and I'll kind of list these in order because you can look at my video and look at the question at the same time. You might not need my video. That's good. So if this whole thing is 54, that means that this whole thing is going to be 126. How do I know that? Because 126 and 54 is going to equal 180. Okay, and this is still a parallelogram, and so since they're adjacent angles, they're going to equal 54. And so again, these get bisected, so I'm going to divide this in half. That would mean that this is going to be, what is that, 63? This is going to be 63, and this is going to be 63. This is going to be 63, and this is going to be 63. Okay, so that's all the information you need to get this done. And so you have answers 1 through 6. So just looking at your stuff, 1 and 2 would be 27. 3 and 4, well, 3 is going to be 90 degrees because that's that perpendicular. 4 is going to be 27. Okay, and so you guys can figure out the rest of that. I don't want to do it all for you, but that's basically what it is. So that's 13, 14, 15, and 16. You're basically going to be doing that. Okay, and so the key is in a rhombus, they bisect each other. All right, move it on. We got another sometimes always true. Okay, and this is for rectangles. And so again, we're going to use that rectangle shape. And so we have to use those rectangle rules. So remember, with a rectangle, because I don't want to spoil any of these, I would draw out your rectangle. Okay, remember, your diagonals are going to be equal, and you're going to have right angles. Okay? But your diagonals don't necessarily bisect the angle. Only a rhombus does. Okay? Can a rectangle also be a rhombus? Yes, when that rectangle is a square. Okay, so remember, that's when you get to sometimes, when it works for a square but doesn't work for every rectangle. All right. So we're going to determine 23 and 24. I'm going to let you answer that. Just use your definitions and your theorems and look at directly. And then 25. I'm just looking at this, and it looks to me like, and I'll probably release this assignment early so you can get it done. I'm going to release it as soon as possible so you can get it done on Monday, even though it's Tuesday's work. So find the lengths of the diagonals. So like on 25, this is the lengths of the diagonals. Because in a rectangle, diagonals are congruent. And so that's how you'd set that up. Well, you can't see anything. So that's how you'd set that up. And so you'll know this problem when you get to it. Okay. All right, and I'm going to let you do it at this point. The last thing that you're going to do is you're going to determine if it is, well, you know what? We'll end here, and we're going to do the rest when you get back to class. That sounds more fun, so I don't have to give you as many problems. Okay, so we'll stop here, and then we'll do the rest in class. All right.